Hey guys, welcome to another A-level maths revision video. Today we're taking a look at some more statistics, and we're taking a look specifically at statistical distribution. So, getting on some of the more interesting stuff here, taking a look at an introduction to the binomial distribution, and taking a look at probability distribution. So let's not waste any more time. Let's start doing some of these questions. So, exercise 6a, question 6. If we change to the right colour pen here. So how would we do a question like this? Well, we've got two functions here. If x is 1 or 3, this is kx, and if x is 2 or 4, then it's the bottom function k times x minus 1. So what we need to do here to find the value of k, or what I would do first is just write down the distribution. So x, so what values can x be? It could be 1 to 4. Okay. Make sure yours is a bit neater than mine. This is probably that x is equal to little x. Okay, so these bottom, the values in the bottom row here will be my probabilities. Okay, mine's really messy, but as long as you get the idea from it, that's the most important thing. So if x is 1, then we're using the top function kx, so k times 1, we just get k. If x is 2, then we use the bottom function, so that's k times 2 minus 1, which is just k again. Do the same with 3 here, but make sure you're using the correct function, that's the top one this time. So that's 3k, k times 3. And then finally with x equals 4, it goes into the bottom one, so 4 minus 1 is 3. I've got hiccups, apologies. So that's 3, and then times that by k, we get 3k. So at this point here, we don't necessarily just get the value of k, we need to actually consider the idea of a probability space. So remember, the probability space here, the possible probabilities should sum to 1. So what we're saying is that the sum of these probabilities here is equal to 1. So in other words, k plus 3k plus 3k is equal to 1. So 6k plus another 2k gives us 8k. If this is equal to 1, then we just get k by dividing by 8. Okay, nice and standard stuff there. Very typical exam style question. Make sure you're confident with this kind of material. Very, very kind of common exam question. And if we want to find the probability that x is greater than 1, so the probability that x is greater than 1, well, given that x can only be 4 possible values, and we want everything greater than 1, that means we can only have 2, 3, and 4. So what are the respective probabilities? So that's k, 3k, and 3k, where k is 1/8. So in other words, that's 6k plus k, so that's 7k. But remember, we know what k is. We want an actual numerical value here. So this is just 7 times 1/8, where k is this value here, 1/8. Okay. So the actual probability then, the probability that x is greater than 1 is 7/8. Okay, so that's all we've got to do for that question. Pretty standard stuff. The other way you could have done it is considering k and doing 1 minus this probability here. It's the other way you could do it if you wanted, but you know, nothing. I think that kind of a bit more of a dragged out way. But yeah, there we go, 7/8 for that one. Next question here, again from the same actual chapter part, I guess, whatever you want to call it. Again, just practicing working out probabilities given the probability distribution. So, A, we want to find the probability that the random variable, or the discrete random variable here, x, lies between 1 and 3, where we don't include 1, but we do include 3. So, this is our distribution here. So I might just do this question in a different colour pen, just so we know which one we're using. So we don't want 1, we want 2, and we also want 3. We're including the 3 here due to the inequality. That means we need this one, and we need this one. So this probability here is equal to a half, 1/2, a half plus this one here, 1/8. Add these together, and you get 5/8 for that probability. Part B here, probability that x is less than 2 So if we're less than 2, again, just use your probability distribution to decide which values we pick. So less than 2, well, the only possible values I can pick is this one here, so this probability 1 over 8, and then this one here, this is less than 2, which means we have this one as well. Okay, so that's 1 over 8 plus 1 over 4. Work this out, and we get 3 over 8. Okay, so hopefully so far again, nothing too tricky. And just one more application again. The probability that x is greater than 3. Well, if x is greater than 3, what possible values can we take? Well, we have a bit of an issue because the highest value is actually just 3 itself. So the probability that x is greater than 3 would just be 0. We can't have it essentially. So just 0 there. Okay, so like you can see, take time with these questions. Make sure you're reading carefully off the your distribution table to find the correct values. But yeah, there we go. That's that question done. Quite a short one, but hopefully nice and easy. Now this question here is taking our first look at a binomial question. So question 6 here. We have a probability of a switch being faulty is 0.08, and then a random sample of 10 switches is taken from the production line. Now, I know, and you probably know, that this is a binomial, given that we're in the binomial section of the textbook, but imagine this is on an exam paper. How do we know this is binomial? Well, the way we know it's binomial is the fact that there's only 2 possible outcomes. It's either faulty or it's not faulty, right? That sounds really kind of basic and intuitive, but that's the main idea. So there's 2 possible outcomes. 2 possible outcomes. We've only got 10 switches. We've got that random sample of 10 switches, so we have a fixed number of trials. So we've got a fixed number of trials. Fixed number of trials. And what else do we have? We also have a fixed probability. The probability that it's faulty is 0.08. So we have a fixed probability as well. So the combination of these here lead us to a binomial distribution. So if I say x is the variable I'm using here to represent it, so we say x is binomially distributed, n is the number of sample on sample size, which is 10, and our probability is 0.08. Okay, so that's just part A there, just 2 marks. These are important. You do need to write these down because that's how we justify our choice. Okay, so this implies a binomial distribution. Okay, so that's part A there. Part B here. Now we want to find a probability using this distribution that we've defined. So we want to find the probability that the sample contains 4 faulty switches. So what we're saying here is the probability is x equals 4. Okay. Now there's 2 ways you can do this. The first way I'd recommend doing it is just doing it on your calculator. In A-level maths, and if you do A-level further maths, I definitely think the graphical calculator is an essential. Some teachers might say that you don't need it, but I think it's really, really important for stats. You'll save yourself so much time, and why go through all the extra effort? So you can do this on the calculator. I'll show you how to do it without a calculator, just in case you don't have one. But if you have a calculator, make sure you need to do this on your calculator. So, doing this without a calculator, we need to use the formula that we know to work out its probability. It's binomial. So, what is this formula? So we've got 10 switches. We want to choose 4. So this is 10, choose 4. We times this by the probability of success, essentially, which is 0.08. We raise that to the power that we want, so that's 4. And then we also times this by the probability of failure, so 1 minus 0.08, so 0.92. And then we raise that to the power of our total sample size, which is 10 minus this power. Okay, so that's 6 there. If you work this out on your calculator, what you should get here is 0.00523. Okay, 2 marks for that. Honestly though, guys, just get yourself a graphical calculator. It'll be the best 40, 50 quid you ever spend. You don't need the mega expensive one. Just get one, about 40, 50 quid. You can sometimes get them cheap on eBay. Definitely take a look. You save yourself so much time. Just get a calculator. But quite a short question, but that's that one done. Next question here, going back to the probability functions. So we've got another random variable x. So the first part asks us to basically construct the table, work it out. So let's see if we can do that first. So we've got x here, the variable, and then we've got our function. So again, x can take 4 possible values, 1, 2, 3, and 4 here. Okay. What we want to do is work out our probabilities. So this time we're not working out a k or anything like that. Makes life a little bit easier, slightly less work. So all we need to do is plug these 4 x values in. So if x is 1, for example, so if x is 1, what do we get? Well, that's 3 times 1 minus 1 divided by 26. So 3 minus 1, so that's 2 over 26. So 1 over 13 there. Okay, so that'd be my first value. I'm going to write them all in their exact form here as well as a quotient. I'm not going to bother basically writing this in decimal form just to not end up with loads of decimal places here. When x is 2, so for example, if we just do this one as well, this would be 3 times 2 minus the 1 divided by 26. So that's 6 minus 1, so that's 5 over 26 there. Okay. We can't simplify that, so yeah, that's just 5 over 26. Doing the same now with x equals 3. So I've done 2, but I might as well just finish it off here. So 3 times 3 minus 1 divided by 26. So 9 minus 1, so that's 8 over 26. And we can simplify this one step further to be 4 over 13 there. And finally, x equals 4. What do we get? So we get 3 times 4 minus the 1, and we divide it by 26 again. So again, for each one of these, all I'm doing is using our probability function defined in the question. So 12 minus 1 is 11, and we divide that by 26. And we obviously can't simplify that any further. Okay, so we just finished with 11 over 26 there. So that's just our probability distribution there. Again, mine's a bit scruffy, but will make yours look a little bit neater. And then, just an application one, we want to find the probability that x lies between 2 and 4. We don't include 2, we're including 4 though. So, we're not including 2, but we want 4. Well, the only possible values then, if x lies between 2 and 4, excluding 2, so we don't want 1, we don't want 2, we do want 3, and we do want 4. Okay, so in other words, we just need to add up 4 over 13 and 11 over 26. Okay. If you're doing this via calculator, you could write that as 8 over 26 plus 11 over 26 to give you 19 over 26 there. Okay. And that's our probability there. Another binomial question here now. This time, we're essentially given the distribution. Well, actually, no, we're not. I can't even read. So we're not. We've got to define it ourselves. So we've got to define a suitable distribution to model the number of green chairs in this sample. So quite a riveting example here. So what's our sample size first? 10. We've got a random sample of 10 chairs. So n is 10. And what's our probability essentially of success? Well, if we're looking for the model for the number of green chairs, if the probability that it's green is 15%, then that's our success. So P, so don't write 15%, right, this is 0.15. Okay. So what's our model? If we say X is the variable that we're using, so X is binomially distributed with n being 10 and P 0.15. Okay. Nothing else to it, just define your distribution. Part B here, we want to find the probability of at least 5 green chairs in this sample. So, if we want at least 5 green chairs, So you need to be careful which way you define the inequality here. If we want at least 5, then we need, 5, 6, 7, 8 and above chairs. Okay. So what we're saying here is that the variable x that we're using to model this situation is greater than or equal to 5. That will always at least give us 5. Okay. When you're doing a distribution like this, or a probability like this, I should say, if it's greater than or equal, what you do is you do 1 minus the probability of, again, the variable x, but this time less than or equal, and then 1 minus this. Okay? Like so. And then at this stage here, you can either do this on your calculator or use the binomial tables in the formula book. Either method's acceptable. I would just use the calculator again, save yourself time. You don't want all the stress of going through the tables in the middle of an exam. So this is just 1 minus 0.9901. You put that on your calculator, you should get 0.0099. Okay. So 3 marks, I like to see, nice and easy stuff. Part C here. Find the probability of exactly 2 green chairs in this sample. There's 2 ways of doing this. In fact, there's 3 ways. Way 1, use your calculator. Way 2, use tables. And then way 3, use the binomial formula for it. This one, I'll demonstrate essentially with tables, because we've already done an example where we work out using the formula. So if x equal to 2, we could actually just write this as the probability that x is less than or equal to 2 minus the probability that x is less than or equal to 1. Okay? If we work that out, we just end up with this. The probability that x is equal to 2. So, what would that give us? Well, using your tables here, so if you go to your tables, make sure you get the exact same values that I do here. That's 0.8202 minus 0.5443. Okay, work this out on your calculator, and what you should get is 0.2759. You can also do it on your calculator. You should get this exact same value here, or you can use the binomial formula like we did for I think it was the second question or the third question, and again, you should get the exact same answer here. If you don't, just double check it. Something's gone, ever so slightly wrong. But that brings us to the end of this video. 5 questions in total. I hope it's helped. If there's anything that's unclear, please just leave us a comment down below. Cheers.